Welcome to this webinar, which will give you a short explanation about how you can use Scia Engineer for the design of civil structures. My name is Jeff Bijens. I'm support engineer at Nemetschek Scia in the headquarters in Belgium. In this webinar, we'll show how Scia Engineer can be used to model civil engineering structures. We'll show you how this often specific load can be applied, and automatically combinations can be generated according to the Eurocode and also according to the Eurocode for bridges. We also have a special node for prestressed structures. So this can be pretensioning or post-tensioning. We also have advanced calculation possibilities with a special attention for different construction stages. And we also show the design according to specific Eurocode rules, like the Eurocode 2. Focus will be to indicate that Scia Engineer is a complete solution for civil structures. Flexibility in modeling is very important for these kind of structures. And there are also very advanced calculation possibilities, as well for the design as the analysis of the most versatile structures, which can also be composed out of different materials. As conclusion, it's important to know that the report can be made very clear and very easy within a very user-friendly and interactive workflow, which also fits into the BIM workflow. So the first topic of our webinar will be about traffic loads. For the traffic loads, there are actually two types of functionality that exist in Scia Engineer: the mobile loads and the train loads. The mobile loads works actually with influence lines, and these influence lines can be used to generate the most critical position for a mobile load on a track. This can be used to search for the critical position of the load system, and it works by means of an influence line. How does this work? You add a track. This track can be a straight line, a curved line. You are actually very free in this. You will add a unit load on the track. It can be one or multiple parallel unit loads. And then you will add a load system on it. This load system can be loaded in from our database or can be defined by the user itself. In the next step, a linear calculation will be performed, the influence line will be generated, and these influence lines can be used to search the most critical position of the load system. This can be used to find, for example, the biggest or the smallest moment at a certain position. But the mobile loads can also be used in a different way to find the maximal and minimal moments over the entire structure due to the passing of the mobile load. These envelopes will take into account all different positions. The second possibility is to use train load. If you're using train loads, you're actually going to apply a load pattern, and this load pattern corresponds to a vehicle or a set of vehicles, a load pattern which can come from our library. But you will apply this load pattern on the structure, and this load pattern will follow your track, and this track will be defined on one or multiple elements, and the load will follow this track, and the load will be placed onto the structure. As you can see, the load will be generated onto different positions, and thus different load cases will be generated, each load case containing the mobile load at a different position. What this functionality actually does, this functionality will generate loads, it will generate load cases, in the same way that you would input them manually. Now in the next step I will show you how to compose a certain type of structure and how you can input the loads on this structure. So in the next step I will show you how to input a structure and how to model traffic loads onto this structure. I have opened Scia Engineer and I will start a new project, and I will start an empty project. It's also possible to use templates, which are foreseen here, but in my case I will start from scratch. I'm using concrete and I'm setting my default material to C40, and I'm using the general 3D environment. And now in the next step, a new project has been started, and it's actually just a goal to follow the main menu from top to down. So I've already set the project data. If I would like to use a line grid, or I would like to import a drawing, use the BIM workflow, then I will do that before I will create the final structure. Now I'm not using those options, so I'm going directly to structure. As you can see in the structure manual, it is possible to input 1D elements, beams, columns, or you can input 2D elements, which can be plate, walls, or curved elements. For this example, I'm going to input a plate. You can see that the preferred material has been set. I can choose the thickness of my plate, and then I will proceed by clicking OK. For the coordinates, I can either just click into the project. For example, I can just click like this, or you can use here the command line to input it in a numerical way. Let's say I want to model a plate, and my plate is gonna be a kind of, the outlines will be circular arcs. Then I can choose circular arc here. Let's say my start point is 0, -2, 0, which means x 0, y is -2, z is 0. My intermediate point is going to be, for example, 33, 0. And my endpoint is going to be, for example, 60, -2, 0. I've indicated that my edge is a circular arc. Now, the next part is again a straight line, and I'm going to say my next point is going to be this point. I can see here in the corner, this point is 60 -2. Let's say we have an edge of 4 meters. Then I'm going to go back to 60. Then I'm going to choose an arclet circular arc, and I'm going to say my next intermediate points, let's say 37. If the other coordinates are 0, I don't have to input them. And the final point is going to be 0, 2. Now, this way I've modeled a plate, for example. And actually, if I want to model a plate or a wall, for the solver in the end, it doesn't really matter. But a wall is easier to input as vertical elements. Let's say I'm going to input a wall which also has 150 millimeter of thickness. And I can even choose to a line. So that option will allow me to just click on a line. The wall will be placed over that line. Just like that. Now, as I've indicated, Scia Engineer is very flexible, which means, for example, this wall is defined by 6 points. As you can see, it is defined by the points for the upper and the lower edge. Now, for example, I can choose those points at the upper edge, and I can just move them. Let's say I'm going to say modify move, and I'm going to place them from, for example, according to the vector from origin to 0, -2. That means I'm going to place it 2 meters further in the y direction. You can see that it easily becomes a curved element. I'm going to do the same thing in the other direction. I'm going to say modify move, and I'm going to say the start point is the origin and the end point is 0, 2. So this way I've defined a vector which indicates how the node should be displaced. So as you can see, I can just easily select points that define the element and just move them. If desired, you can also just select it and move it with your cursor. That is also a possibility. Okay, if you want a bridge like this, usually it's not very easy to create. Now for the next part, I can even move this system. Let's say tools, UCS, let's move it. And I can put my modeling system there. Now, if I input coordinates, they're relative to this system. They were already relative to that system, but I can easily move that system. Now, it is also possible to reuse the plate at the bottom. Since I know that the top plate should actually have the same geometry, but should just be a bit wider. What I'm going to do, I'm going to modify, copy it. I'm going to copy it, let's say, from here to there. Copy the add data as well, so in case I put loads and data properties on it, it's going to copy them as well. And I'm going to pick some of the coordinates that define its outline. You can see if I can select multiple parts in the project, then it will give me a clear choice. And if I'm going through my choices, it will indicate in a red line what I'm trying to choose. And these points, we will place them, for example, we will move them to this part. As you can see, now I've made the structure. Now I've made a type of bridge. And also in this menu, I just actually have to go from top to down. So you can see we have a possibility to use load panels. Now load panels are normally not used in combination with plates. Load panels are more used if you have, for example, a steel structure with steel elements, or you have just a type of structure without any plate elements, but you do want to use surface loads. Then you can use the load panel, which catches the loads. Like for example, having a steel hull with a lot of windows. Then you can use load panels, which take loads just like your windows would, for example wind. But load panels do not contribute to the total stiffness. We have advanced input. It's possible to use certain blocks or to just combine projects. But I'm going further because I want to apply supports. I'm going to say, let's say I have a line support here on this edge and one on this edge. Line supports. Then finally I'm going to connect member nodes. Why? To make sure everything is connected. It will say I've created 2 new intersections. It has here connected these edges. I'm going to do a check of structured data. This is a check for the projects. Normally nobody makes mistakes, but it does not mean that they are impossible. Now in the end I want to apply a traffic load. To apply a traffic load, I'm going to go into loads. So if I want to go into loads, I need a load case. Scia Engineer can automatically create self-weight. I'm going to make a new one and I'm going to say, well, this will be my traffic lane. Of course, I'm going to pick a variable one. You will see here traffic loads. Now, how does this work? First, you make a traffic lane, and then you're going to apply a traffic load to it. I'll start with creating the traffic lane. Now, I'm going to say, for example, that my traffic lane is a circular arc. So I'm going to start here at the middle. I want to choose the midpoints. Okay. So you can see here midpoints. Then I can even choose irregular points, but I'm not gonna do that. Yeah. Anyway, you're free to go as you please with the traffic lane. Okay, I'm just gonna follow here the middle of the element. And this is the traffic lane on the structure, on my bridges. This is the lane that will be used to apply the traffic load. So in the next step, I will go to the lane loads manager. It will ask me to define a train load. Now, it is possible to define one yourself, but I find it too much trouble, so I'm not going to do it. I'm just going to pick something from our system database. You will see there are a lot of options in our system database. I will put them all in my project. And then I have an overview here of the different traffic loads that come from our system database. For example, I want to use, let's say, this one. You can see here these are point loads of 150 kilonewtons. 150 kilonewtons. The distance between them are 0.75 meters. 0.75 meters. And the reference point is this red point. So this red point will follow my traffic lane. Okay. Now I have a traffic loads. It will follow the lane TR1. It will create loads, and the loads can be used in a combination. If I want to use them in combination, I will have to indicate, for example, that it's the type of loads they are not meant to be together in a combination. They are exclusive. They are variable, and for example, those are heavy vehicles. Okay. It's going to create load cases, and the load cases will contain a step of 1 meter. So it will create load cases, and it will create load cases each time with the load 1 meter further and further. Okay. And now we will see here. You will see here that it will generate load cases. While I click generate load case, the system will create multiple load cases. I will show them to you. First, the load is at 0 meters, and each time it's 1 meter further and further. So this is my mobile load passing over the bridge. Now that I've shown you how you can create a model and how you can model traffic loads, I will explain you a bit about the load combinations. So in Scia Engineer, it's possible to automatically generate combinations according to Eurocode 0. What I'm going to show you now is an extension of those automatic combinations. This extension will use the appendix 2 from Eurocode 0. What does this tell you? If you want to combine loads independently from the material, because Eurocode 0, then you will have to use different rules for either road bridge, footbridge, or railway bridge. You will have to use a combination factor and a load coefficient. And there will also be a leading and accompanying load. Besides those rules, there are also special rules that tell you this type of load and that type of load can never be combined. Now in Scia we can easily make those combinations. We will combine the load cases according to these rules. In the national annex you will see different parameters are foreseen. Now the normal type of combinations, we call them building combinations. And this extension which I'm explaining now are the bridge combinations. In the bridge combinations there are combination setups, the psi factors and the load combination factors, like indicated by Eurocode 0 appendix 2. And then the same way you will indicate in Scia Engineer that your loads are from a specific type, and due to this type, if you indicate this type, then Scia Engineer will be able to find the according psi factors. So the left image, that's when you're creating a certain load. And the image on the right, that is from the national annex. Those are the parameters stored in the national annex. It will go the same for footbridges, and it will also go the same for railway bridges. And there will also be variable load coefficients. There are variable load coefficients for the leading loads and the accompanying loads. And besides that, there are also the different rules which are by default activated, but which you can also yourself modify. And now if you want to use them even further, you just indicate what type of bridge you have and then it will use the correct kind of combinations. Now I will show you live how we can use the bridge combinations in Scia Engineer. Now in Scia Engineer I'm opening a project, and this project contains actually a type of prestressed bridge. In this type of bridge the bridge combinations will be used. Now for this example, I'm using a bridge with post-tensioned cables. So in Scia Engineer this project has used bridge combinations. Now what are the requirements for bridge combinations? Well, first of all you're going to tell the project that you want to use bridge combinations. So you have the bridge design, a specific functionality, and you just activate it when you want to do a bridge design. In the bridge design you have sub-functionalities which you just activate. The most important one of these is the load combinations. Now how does it work? Well, we have different load cases. They are foreseen here, different load cases. And actually each of those load cases, they have their group which are divided to. And in the group you would tell them, well, it's a road bridge and the type of load is a thermal load, for example. In this way the program knows, okay, these load cases are meant to be together or not meant to be together, and if I want to combine them I have to look to these and these coefficients. Let's say I'm going to go back and I'm going to create my own new load case. Okay, let's say this load case is, for example, my new one. I'm going to tell them, well, it's going to be a variable load, and the load group, well, I think I'm going to create a new one. And it's, for example, this kind of load is, for example, let's say traffic load, which takes into account the horizontal forces, and to kind of loads, for example, for, let's say, road bridge. Okay. Let's call it GR2 horizontal loads. There you go. That's how I create a new load case, and I'm going to tell the program this load case is this type of load. I can even use this in my construction stages. Then I just tell the setup, well, my construction stages, they're about a road bridge. What will the software do? It will automatically create those combinations. I can even show you, for example, if I'm going to, let's say, the content of combinations. you can see for phase 1, it actually has different types of combinations, and you will see that the coefficients change in different phases. So in these combinations, the rules for the coefficients, the special rules, and the leading and the following combinations are immediately taken into account. Now, next part, I'm going to tell you a little bit about prestressing possibilities in Scia Engineer. So prestressing actually refers to either pretensioning or post-tensioning. First of all, I'm going to explain you a bit generally about the materials. Actually, the type of strands or wires or bars that we are using are indicated into the materials. You can see here, for example, in this material, you see the Y1960 S3. This means that this is actually a string composed of 3 wires actually, and it has a total diameter of 5.2, and the allowable stress in it is 1960 megapascal. And each of these materials, they contain relaxation parameters. So there's a table for each prestressed material. You can also see and show these values, and these values will be used to calculate the losses in the cables. But also it's possible that you edit them yourself. Now for post-tensioning, we actually have 2 types of tendons, internal and external tendons. Either way, you can input them on 2 different ways. Actually 3, but there are 2 possibilities, and the third one is a mix of those 2. You either do it directly, which means that you do it directly into the model. You can either do it directly in the model by inputting your coordinates yourself, or by clicking onto the correct points yourself, or just by importing a DWG file and just following that. Or the other way is through a source, and the source, that's actually a table. So in the table you input, well, the height is 0.2 meters or 200 millimeters. And the combination of that is actually that you're going to input a reference line in the project, and then the coordinates in the table are going to follow that reference line. And then immediately it can calculate some losses, like for example friction losses, anchorage sets, and losses due to sequential stressing. If you want to input the tendons directly, you can either do it manually or from drawing formats. And afterwards it's also possible to change these coordinates, these positions, or even parameterize them, so that you indicate a parameter as the certain distance or height. The other possibility is source geometry, and as you can see in the image, here you're actually just inputting numbers, and these numbers still have to be inputted into the software, into the model. You can also import these numbers from a text file, and they can also be parameterized or used through XML. And then the third option was actually a combination of these 2. For example, you make this inclined line in your source geometry, and the reference line, that's something that you input in the model. For example, in my 3D model, I'm going to input this curved line, but my source geometry says that I actually have this inclined line. The combination of these 2 is a spiral. Now for free tendons, you actually have 2 possibilities again, but you can have an internal free tendon or an external free tendon. For example, you can have free tendons like this, or you can also have them freely in the model as indicated in this image. They can be fixed in deviators. You also can find the stress after anchoraging, and you can also put specific tempered load onto your free tendons. Now after I've explained this bit about post-tensioning, I will show you into Scia Engineer how this works. Now in Scia Engineer I have a model, and in this model I'm going to input my pretensioning, actually my post-tension cable, by means of a DWG form or DXF file. So if I want to input the DXF file, I'm going to go to Structure, I'm going to choose Modeling Drawing, import DWG DXF. I've provided a file, I'm going to open it. Now this is a 3D file and I'm in a 2D project, so it will be planarized. Let's continue. And you will see here that actually this file normally should provide the DWG or DXF with continuous polygons. Here it has not been provided. Now I can also use the different layers that are in the file. So I'm gonna deactivate the lines, arcs, def point, prestress. Actually, I just want the prestress part. Okay, that's perfect. I can use this. Now what I'm gonna do, these lines are separated parts. I'm gonna combine them. I have the tool for this. Start, select them, run, and I'm gonna import them. Let's say I'm gonna take this one and I'm gonna import selected. Choose OK, and I can place it here somewhere in the project. Now, of course, this is a very long tendon. This is no more than a line. Now, to input my post-tensioning, you can see here I have tendons post-tensioned internal tendon. I'm just gonna pick here direct input. Now, in the properties, I will show you this window. In this properties, I can give extra properties for example, the material which I'll use, the number of tendons I will combine, and how much groups I will combine. Okay, which load case I will input it, and how the stressing is performed. Now, for my material, you will see here I have this C, that means a cable. But you have the C's, the cables. You also have the S, those are the strings, or the H, those are actually the beams. Now I have a cable diameter 3, and I'm going to combine, let's say for example, I'm going to combine 7 of them, and I'm going to set it into, let's say, 3 groups. That gives me a total of 148 squared millimeters. And I'm going to place this tendon into the project, and to make it easier, I'm just going to follow my DWG. So I'm choose select line, and I can just pick this line. And now this is my tendon in the material. Of course, this does not work. I think this is logic. This is very logical. It will not. This does not work. I also have to say that I have, for example, let's say I have this element, and my element, of course, should have sufficient heights and sufficient length, because the tendon must fit inside it. So let's say, for example, if I want to use this as a project, that I would have to have, let's say, a beam that would be 5 meters by, let's say, 3 meters. In this way, we would have modeled a beam with a post-tension cable in it. All you have to say is, well, you have to allocate it. It's going to be allocated to this element, and now they are attached together. If I pick the beam, you will see in the properties of the beam that it has this post-tensioned tendon as data. Now, after the post-tensioning, I will explain you a bit about pre-tensioning. First of all, you will start off with a stressing bed. In the stressing bed, you will have a borehole pattern, and in this borehole pattern, you will place the pre-tensioned elements. Now, in the stressing bed, for example, you can already take into account the losses, for example, due to temperature losses, due to just deformation of the elements, or the speed up which you can have by the temperature effects. And it will be translated into actually this image. What this image indicates is you have to indicate what your stressing bed is. It's actually the steel block where your prefabricated element is created. And then the next step, you will put your wires in it. In Scia Engineer, the result in the 3D will be this element, for example. As you can see, it's also possible to create pre-tensioned elements, prefabricated elements, which have deviated wires, which have deviated tendons. Now, both for pre-tensioning and for post-tensioning, we can take into account different types of losses. You can see it here for pre-tensioning: elastic deformation, relaxation, deformation of stressing beds, temperatures, And for post-tensioning, you have also these different types of losses due to your post-tensioning. You have friction losses, you have the anchorage set. So these are very typical to post-tensioning. And you also have long-term, we have these losses that you can take into account for both types of prestressing. So for example, for the post-tension tendon, you can see your short-term losses immediately, or you can also later on see your long-term losses. Now, I will show you an example of a post-tensioned element with these losses. Now, in this file, we will have a post-tension bridge with, of course, post-tensioned cables. You can see in this element, different tendons have already been inputted. They have also been put into construction stages. Now, I'll explain the construction stages later on. But by applying them in construction stages, you can indicate which elements and which tendons are added first and which others are added later. This also allows the program to take into account your lossing due to sequential stressing. The immediate losses to which I referred can be viewed when you select this tendon. For example, if I pick this tendon, I can immediately see what are my tendon losses. It will show you my tendon losses. The image might not be clear, so I will up the text scale. You can see friction losses there. And due to the friction loss in your anchorage set, you can see that the stressing is applied on the right hand side, on this side. Also in the table you can view those values. So actually you have at position 0 you already have loss due to friction. You have anchorage set loss, which is set to 0. Short-term relaxation, which is not calculated yet, there. And you have stress after anchoring. And the relaxation which comes is this quantity. Now in the end you will go to the calculation, and if you have performed the calculation you will have results, and in the results you can ask for the tendon stresses. Now the tendon stresses will show you, for example, let's say we have phase 1 ultimate limit state, and we will do it for the current tendon, the one I selected. In phase 1 it is not there yet. In phase 2 it's still not there yet. In phase 3, okay, it's still not there yet. In phase 5 it has been added. What you see here is the stress after anchoring. So this is the stress in the tendon immediately after it has been placed. I can also go to my preview to see these results more in detail. The preview gives you the tabled results of what you see in the image. You will see here that the stress which is shown in the image is the stress after anchoring. You also have other losses, so LAD, loss due to sequential stressing, etc., etc. Now if I go further, let's say I go to, for example, phase 7. If I go to phase 7, you will see that the stress in this element has been reduced. It has been reduced due to what you can see here, LED, loss due to sequential stressing, because others have been added. And also LCS, loss due to creep and shrinkage, and loss due to long-term steel relaxation. And then you can go even further in the phase, let's say phase 17, which is after 1 year. You will see that these losses become even higher. So this allows you to inspect the stress in a tendon at each point in my post-tension bridge. You can even go to a phase. We have made a phase at a time that equals 100 years, and then it will be able to watch in the preview how the stress changes. So the loss due to creep has become very high, and the stress that remains in the element has become much smaller. When the stress that we applied initially was 1327 at this position, due to friction losses you did not apply more. But after 100 years, this stress has been reduced to a small 1200 megapascal. And you can see there has been some significant loss due to creep and shrinkage and a small loss due to sequential prestressing. Now I can also immediately inspect what, for example, certain results are in a certain phase. For example, let's say I'm going to pick the load case where certain prestress elements are applied. So all the tendons which are connected to LC3, load case 3, all those tendons together, they will apply this moment. All the tendons which have been connected to load case 3, they will apply together this moment. Now let's say I'm going to show for 0 degrees add units. I can modify the image a bit to make it more clear. Now we will also see here this button Prestressing. Now if I put my mouse to it, it will give you a short image. This image should explain it a bit. But if you look at the moment due to prestressing, then you get several jumps, positive and negative moments. But the moment that has been introduced to the prestressing, it is not equal to just taking the normal force from the prestress and multiplying it with its eccentricity. If you would do that, you would have the primary forces. The primary forces give this moment. So actually you're picking these tendons together and they would give this moment. But, very important, you also have secondary forces. Due to applying the prestress, you're creating a hyperstatic structure. And if you have a hyperstatic structure, then you're going to lose a part of your moment because due to your prestress, the structure wants to deform. But this deformation is not allowed because you have supports. And does the support give a reverse moment? Because they block this deformation. And this reverse moment, those are the secondary forces. Now what you take into account is the combination of the prestress and the secondary forces. This is what you can see here. Now, as I shortly indicated in the previous project, we used construction stages. We use construction stages to indicate that the project has been built step by step. Now, construction stages are used in various projects and certainly in civil structures. We have three types of construction stages. First of all, we have the linear construction stages. The linear construction stages allow you to create a model step by step. Then we have some more advanced construction stages, which are actually an extension of these normal construction stages. For example, you can take into account that the E-modules changes in time. So the strength of your concrete and elasticity of your concrete changes in time. You also have your time-dependent construction stages, or TDA, time-dependent analysis. And in your time-dependent analysis, you also take into account concrete aging, creep and shrinkage, tendon losses. So actually the reason for these different types of construction stages is because if you want to use construction stages to build step by step, then you can just use those linear construction stages. If you want to go to a more advanced type of construction stages, then of course the program needs more input. And then it becomes more complicated because you will have to give in certain data, and this data will be taken into account for different types of effects. Of course, of all your data, you have to obtain them, which is not always that easy. For this example, it is a model that has been created with construction stages. It's actually a simply supported beam, but it is built in specific steps. So first there are columns that are added. You can see them, they are nicely indicated in green. In the next step, we put a beam between those columns. In stage 3, the beam has been extended and supports are added. And finally, the columns are deleted and temporary supports are used. And in the end, those temporary supports are also deleted. What do you get? Well, if you look at the different moments in each part of the time analysis, of the construction stage analysis, well, of course, you have different structures each time. And the structure in the next phase continues with the deformed structure in the previous phase. Now, if I go a bit further, Then you will see in the final envelopes of the results, you will see which types of moments are indicated in the beam. Now the construction stage analysis allows you to firstly to look at how the elements are modified and which position you will get by using the modified elements. So if you look at the end results, you will see that it is possible to look at all the different types of forces that are applied into the different elements each time in this construction. For example, for the simply supported beam, if you would model it with construction stages or would not model it with construction stages, either way you would find that the total moment in the middle would be 16.55. But what you would not find is the moment of minus 3.68 and the other moment minus 1. These come from the construction stages. Now in construction stages you can also use construction stages for the to indicate that a section changes during time. For example, if you have a prefabricated beam and this prefabricated beam is used to create a bridge, then normally a concrete plate will be cast upon these prefabricated beams. You can also take this into account by modeling the prefab element, the prefabricated beam, as single beam and the plate that will be added later on as part of the section that will be added later on. And this type of construction, this type of section can also be taken into account into analysis, into the construction stages. And with the time-dependent analysis, it's also possible to take into account the differences of creep and shrinkage between those elements, and the age at installment of each member and different time axes. The time-dependent analysis is actually a numerical method that follows a part of the annex in Eurocodes 2.2. So what we do is nothing more than just following procedure prescribed by the Eurocode. Other than this, there can also be different other types of methods or structures that can be modeled with construction stages. For example, this kind of bridge placed in the Czech Republic has been also placed. This kind of bridge has also been calculated with construction stages in Scia Engineer. This bridge has now a length of 356 meters. So another example of construction stages is, for example, the bridge across Rybný Brook, which is a bridge of 356 meters in the Czech Republic. It has been calculated with construction stages. Another example is a cantilever construction. This is also being used in Slovakia, and the total span is, I believe, more than 200 or 300 meters. The cross section is cast in situ by using prefabricated struts. They are using internal and external tendons. Another example which I will show you is a temporary suspension. This temporary suspension has been used to create this arc. But to calculate this arc, the calculation had to be very precise, because during construction, well, the final point that you will achieve is the middle of the arc, and you do want those 2 points to match. The temporary suspensions have been also modeled in Scia Engineer to find the results. I will go to the construction stages and show you how it has been done. So I'm just going to run through, and actually I don't believe I have to explain very much, because the image and the red and the green parts will explain to you what has been added and what has been removed. So each time a separate block has been added, and then a cable has been added. This allows you to look at how this block is deformed, and then you're going to add a cable, and this cable has, of course, certain stiffness. These cables here are post-tensioned free tendons. So, of course, also losses will be taken into account. Step by step, this process is continued until you find the point in the middle. And of course, very important part is that the 2 points have to match, which of course not always that evidently. Now these construction stages can also be used in different ways. For the design of pre-tensioned elements, we also have the 2D 1D upgrade. This allows you to go from a 3D model to actually a 2D model, so that you actually go from sort of kind of plate model to a beam model. What happens? You apply a load to a 3D structure. You can see how the forces are divided into the element. And after this, you're going to apply the 2D 1D upgrades, and you're going to take a part of that plate to calculate it more in detail. And then this separate part can be calculated very precisely, also with time-dependent analysis, to find what different forces and stresses are at each point in the time, and to check the shrink, creep, etc. So this has also been this example has also been applied into real-life projects, as you can see here. Now we also have concrete checks that follow Eurocode 2.2. And you will see in our concrete menu there are different types of checks. We have checks of non-prestressed and checks of prestressed concrete. And besides those checks, there are also separate controls. So you can check the crack width and decompression. You can check the capacity, and if you check the capacity, then you can check into the section what are the different strains and stresses. So when you are checking the capacity, or you are checking the amount of reinforcement required, it will check it based onto the cross section with the reinforcement in it, or the post-tensioned cables or pre-tensioned cables in it. So it will combine the rigidity of the section and the pre-stressed elements in it to find the total stiffness of the section. Other than that, you have still a capacity check, where you can check in a 3D diagram whether or not it can take all the forces. And you can also check the joints. For this, of course, you have to indicate how the joint is created. Is it a smooth joint or is it a rough joint? You can check the stress limitations. You can check pre-stressing. And of course, it will take into account different parameters, the different values that the national annex provides. We have different national annexes which are provided. This is an overview of Scia Engineer 2013. Of course, we are by now much more advanced. We have a lot more of them. And besides from the different points that I've shown you, there is also other types of analysis. You have the nonlinear construction stages, you have the dynamic or the seismic analysis, sequential analysis, nonlinear calculation, steel check, pile design, and also many other types of advanced analysis, which can also be used for civil engineering, but which I have not included in this webinar. Now this was a bit what I wanted to show you. I've shown you a bit about variable traffic loads. I've shown you a bit about how you can combine loads. I've shown you a bit about pre-stressing, about construction stages, and the concrete checks in Scia Engineer. And I would like to thank you for your attention. We hope that this webinar was very interesting and that you learned a lot. I think it's also obvious that you can still contact us for more information. We also offer you a free trial version so that you can discover all these possibilities yourself. And for this, we would like to invite you to our website for more information and for this free trial.